Hi everyone, I'm Paul, and welcome to another episode in our series of video tutorials from Lens Pro to Go. Today's episode is being shot on two Canon 5D Mark II DSLRs with two super pieces of L glass. On this camera we have a Canon 24-70 f2.8L, and on this camera here we have a Canon 85L, one of my favorite lenses of all time. Today we're going to talk about camera sensors, in particular about the size of sensors on various DSLRs on the market. Now, most cameras use CMOS sensors, where CMOS stands for complementary metal oxide semiconductor. Did you get that? I didn't think so. I didn't get it either. So let's talk about something that we can understand, and that's about how different size sensors in various cameras affect our images. There are three different size sensors for Canon and two for Nikon. So let's start with full frame, which is approximately the size of a 35mm film frame. Now on the Canon side, there's the 1DS Mark III, the original 5D, and the 5D Mark II. And on the Nikon side, there's the D3X, the D3S, the D3, as well as the D700. These are all full frame cameras. Next size down from full frame is Canon's APS-H size sensor, which is unique to Canon in the 1D series bodies like the 1D Mark III and the 1D Mark IV. Now, because it has a smaller size sensor, we have to multiply the focal length of any lens we put on there by 1.3, and we'll show you examples of that later. Next, we have the smaller APS-C size sensors, which vary in size depending on the manufacturer. For example, Nikon utilizes a 1.5x crop factor on their cameras like the Nikon D300, the D300S, and the D90. On the Canon side, they utilize a little bit smaller 1.6x crop factor on their cameras like the 7D, the 50D, and the Digital Rebel series of cameras. Now, it's not important to know the exact size of your sensor in your camera, but it is important to remember the crop factor, and here's why. Let's start by drawing a camera here and assume that we have a 100mm lens attached to this full frame camera. Now let's say we're photographing this young lady here, and this is our frame. Since we have a full frame sensor, this is the picture our sensor would see through a 100mm lens. Everything is fine, and we have exactly what we're looking for. Now, pretend we have magical powers to stop time and replace the sensor in the camera from full frame to, let's say, APS-H size sensor from a 1D Mark III or 1D Mark IV, which has a 1.3x crop sensor, and that's quite a bit smaller than a full frame. Well, having a smaller sensor in the camera will only allow us to capture this much of the original scene. Remember, we only changed the sensor, but everything else remained the same, including the same 100mm lens. As you can see by the result, our image looks like we've changed the focal length from 100mm to 130mm. Now, let's switch our sensor again to a 1.5x crop sensor from a Nikon D300. Our scene just got cropped again, thus showing us much less of the scene. Canon's 7D and 50D and Digital Rebel series of cameras sport yet a smaller sensor, which has a 1.6x crop factor, which, as you can see, crops our scene even more. And here's the entire image with the sensor overlays just for reference. Now there's another thing that is greatly affected by the size of the sensor, and that's depth of field. Now, we're not going to bore you with all sorts of technical information in terms of how and why that's done. And there's been various threads on all sorts of different forums, and people argue endlessly about this subject. So instead of talking about it, we thought it would be best just to show you. We had Tony set up a quick shot of the same scene with two different cameras. And to exaggerate the results, we're using a Canon 5D Mark II full frame camera and a Canon 50D, which has a 1.6x crop factor. We've mounted a Canon 100mm macro lens on the 50D and Canon 70-200 2.8 IS on the 5D. We've taken a series of shots from the same position of the same scene with two cameras. This first image is taken with the 50D at a 100mm focal length. The next shot is from the 5D, also at 100mm. As you can see, we've covered a wider view of the scene using the full frame camera as we've discussed previously. Now, let's take that same shot and crop in to create the same exact frame as we have from the 50D. As you can see from this view, there is almost no difference in the depth of field. There is some difference, but it is so minute that it's almost unnoticeable. Now, let's think about our setup for a moment. We have our 50D with 100mm lens attached to it. Knowing that our 50D has a 1.6x crop factor, our 100mm lens becomes a 160mm lens, since 100 times 1.6 equals 160. So, to get the same field of view from the two different cameras, we use a much longer focal length when using a full frame camera. So we're going to zoom to 160mm on our 70-200 on the 5D. And since longer focal lengths produce a more shallow depth of field, that's one of the reasons that many portrait and wedding photographers prefer to use full frame cameras. The same lens will produce not the same but similar depth of field results, but it's those longer focal lengths, all other things such as aperture being equal, will always produce more shallow depth of field. There are a couple more factors you might want to consider when trying to decide which camera and which sensor is right for you. Cameras with full frame sensors are generally better at handling low light situations, but there's also a price factor because full frame cameras are also generally more expensive than crop sensor cameras. However, if you're a sports or a wildlife photographer, you may actually benefit by having a camera with a smaller sensor because those longer focal lengths that you need to shoot sports and wildlife become even longer when you're using a smaller sensor in your camera. So it really depends on the kind of photography that you're doing and your budget as well when trying to decide which camera is right for you. Hey, you still here? Well, thanks for watching our tutorial on sensor sizes. We hope you found it valuable, and we'll see you next time.